and in this section we're going to connect infinite limits with vertical asymptotes. We're going to talk about what happens with unbound behavior. And unbound behavior is when your graph goes up or down without bound. In other words, it goes to positive or negative infinity from different sides of the equation. If you have a polynomial equation with a numerator and a denominator, the possibility exists for you to have vertical asymptotes. With vertical asymptotes, remember, that's only going to happen if you have factored the polynomial completely, but then you still have something on the denominator that didn't cancel. Whatever didn't cancel out is going to be considered a vertical asymptote, as long as you can set it equal to 0 and find the number for that. Remember, if it canceled in the last section, we learned that if something cancels out, it's a whole. It's still a discontinuity, but it's not an asymptote unless it doesn't cancel out. So here I have 4 different examples of the possible outcomes when you have vertical asymptotes. You could have possibly a vertical asymptote where both of them approach infinity without bound. You could have a vertical asymptote where it approaches infinity from the left, but approaches negative infinity from the right. You could have a vertical asymptote where they both approach negative infinity, and you could have a vertical asymptote where the left side approaches negative infinity and the right side approaches infinity. You could also, for all of these, have horizontal asymptotes somewhere, depending on the degree of the numerator and the denominator. So we'll talk more about that later. So these are the 4 possibilities of unbound behavior. And in order to figure out what that unbound behavior is, I encourage my students to graph it using either Desmos or a graphing calculator. We use the calculator so that we can save ourselves time. I'm not somebody who likes to tell my students to memorize certain facts, like if this happens, then you've got this situation, or if something else happens, you've got this situation. To me, memorizing math isn't really conducive to learning it, so I always encourage my students to graph things rather than memorize different facts. Now, you may see some connections as we go through these things, and that's fine, but I would never assume something works all the time. I actually graph it either on a calculator or by hand, just to see logically what's happening with the numbers. Here I have a function, f of x equals 3 over x minus 2. It's a polynomial function with a numerator and a denominator, and they're asking us to find the limit as x approaches 2 for that function. So if you look at this, it's not factorable on the top or the bottom, so there's not going to be anything that's going to cancel out. So right off the bat, I know I'm going to have a vertical asymptote at the number where I set that denominator equal to 0. So if I set x minus 2 equal to 0, x will equal 2. So that means there's a vertical asymptote at 2 for my graph. So I know that pretty much right away with just a little bit of investigation. So here's my vertical asymptote. Now, we will review horizontal asymptotes again later in the chapter, but if you're looking at this with your knowledge from Algebra 2, if the degree of the top is less than the degree of the bottom, then you have a horizontal asymptote at y equals 0. So that means my x-axis is also an asymptote. So that tells me that my function, I know, is either going to increase or decrease. It's going to increase or decrease without bound, and I just have to figure out what's happening here. So I know I'm going to have either something like this, or maybe this and this, but I know my graph, based on the asymptotes, has to be in, each section has to be in a specific kind of quadrant area of these 4 portions of the graph. And so if I just look at the numbers here, if I plug 0 in, 3 over negative 2. So at 0, my answer is going to be down at, I'll just say negative 1.5. I'll just stick it there. I don't know that that's exactly where it's going to go. If I plug 1 in, I have 3 over negative 1. So 3 over negative 1 would be at negative 3. So that's down a little bit further. So this shows me kind of the direction that my graph is going. It's going down toward infinity, and we know it's not going to cross that horizontal asymptote. So that's the left-hand side. And then if I look at the right-hand side, in order to get this portion of the graph, I need to plug in numbers to the right of the asymptote. My asymptote was at 2, so numbers to the right, let's plug in 3. Well, 3 over 3 minus 2 is 1. 3 over 1 is 3. So at 3, I go up 3. And then if I choose 4, 3 over 4 minus 2 is 2. So at 4, I'd have 3 halves. So that's about halfway. So that kind of shows me that my graph is looking something like that. So here's an example where you have unbound behavior. The left-hand side is going toward negative infinity with outbound. The right-hand side is going up toward positive infinity with outbound. In the next one, g of x equals -1 over x plus 1. They want you to find the limit as x approaches -1 for g of x. Well, as x approaches -1, we have to determine if there are any asymptotes. Nothing factors, so there aren't going to be any holes. When I set the denominator equal to 0, I get x equals -1. So I know pretty much right off the bat, I have an asymptote at -1. Again, the degree of the top is less than the bottom, so I also know I have a horizontal asymptote at the x-axis. And then, again, I'm just going to plug in some numbers. So I'll do the right-hand side first this time. If I plug in 0, I end up with -1 over 1. So at 0, I have -1. I'll just say that it's about right there. If I plug in 1, I have -1 over 2. So that would be -1/2. So at 1, I have -1/2. And I could continue this pattern and I would notice that in this direction, it's approaching my horizontal asymptote. In this direction, it's approaching my vertical asymptote. Then if I go to the left side of that -1, I could plug in -2. If I plug in -2, I'll get -1 over -1. So at -2, I'm going to have a +1 this time. And then if I plug in maybe -3, I would have -1 over -2, which is a +1/2. So you can see that this function is going in this direction, approaching the two asymptotes. So again, we've got them approaching two different infinities. As we move in from the left, it approaches positive infinity. As we move in from the right, it's approaching negative infinity. With these functions, I've been graphing them by hand. You certainly have the option of graphing them using your graphing calculator. That's fine. And that's what I would do usually if I'm doing this to save myself time. But I do think it's important for you to understand where these numbers are coming from, because part of the AP test is non-calculator. So it's important that you understand how to do this without a calculator. That's why in the videos I'm showing you without one, but certainly use that calculator to help you with that. Okay, in this one, I don't have anything that will factor. If I set the denominator equal to 0, x will be equal to 0, so there's an asymptote at 0. So I actually have an asymptote at x equals 0. If you look at the degree of the top and the bottom, again, the top is less than the bottom. So there's also a horizontal asymptote at the x-axis. And then we have to determine what's happening on each side of those. So I could do on the right, if I plug in, let's just say 1, I would get 1. 2 gives me 1/4. 3 gives me 1/9. If I plug in like 1/2, I would get 4. So you could plug those numbers in. So basically what's happening here is as I approach from the right, it is getting bigger and bigger. So my asymptotes are approached in that direction. And then if I look at the left-hand side, notice when I plug negative numbers in, the top and the bottom are both going to be positive. That tells me my graph will be above the x-axis. And so if I just go ahead and plug in some numbers, if I plug in -1, I'd get 1. -2 gives me 1/4. -3 gives me 1/9. If I plug in -1/2, I would get 4. So that tells me that my graph is going in this direction. So they're approaching positive infinity from both directions. So my limit here would be infinity. Now remember, in the other ones, I didn't really answer those questions, but they were approaching different things from different sides, so we would have to say in those the limit doesn't exist. But in this one, it approaches infinity because they're both going up. And then here, in this one, again, my vertical asymptote is the y-axis. My horizontal asymptote, for the same reason as before, is the x-axis. And now if you look at this, the top will always be negative and the bottom will always be positive. If you think about numbers there and how they work with squares, thinking about your number theory. So if I plug in a negative number, then I'm going to end up with a negative. If I plug in a positive number, I'm also going to end up with a negative. So that tells me that on these, everything's going to be underneath the x-axis. And then if I just plug in some numbers, like 1 will give me -1, 2 will give me -1/4. So if that's the case, it looks like it's approaching this direction. And if I were to guess, I would say it's probably approaching in this direction. But we could do some numbers. If I plug in -1, I would get -1. If I plug in -2, I'd get -1/4, -3, -1/9. And you can see it's approaching the x-axis on this side. And if I plug in something like -1/4, that would be 16. So it goes down very, very quickly. So you can see here that this one, the limit here, as we approach 0 from both sides, is -infinity. So these two had limits. The first two did not. They were does not exist.